Okay, guys, this is our homework for 322. And so we're just gonna walk through it and talk about it, how to do these. So for number 3-84, it says on graph paper to show how to draw figure 0 and figure 4. So the first thing that I would do is count up how many tiles are in the figures that you have. So I know that figure 1 has 4 tiles. Figure 2, right, has our 4, 5, 6. And figure 3 has 1, 2, 3, 4, 5, 6, 7, 8. All right, so after I have that, then I'm going to start looking at how my pattern is growing. I can see that it's increasing, right? As we go, it's increasing. And how much is it increasing by? We're adding 2 every time. Now, if you're not sure where the 2 are being added, I'd encourage you to shade in the previous figure on the next one. So I'm going to shade in on figure 2. I'm going to shade figure 1. So I can see that I have these 2 tiles, right? A stack of 2 going up and down. And then I have 2 next to it going across. Okay. So now that helps me really to be able to see like, oh, there's 1 added here and 1 added here. And if I'm still not sure and I want to make sure that it's correct, I can shade figure 2 onto shade figure 3. So I can see I have a tower of 3. So 1, 2, 3. And then across 1, 2, 3. 1, 2, 3. So I can see, again, I'm adding 1 on top and I'm adding 1 on the side. So when I go to do figure 0, I'm just going to be subtracting those off, right? So I'm subtracting 1 off of the top stack and 1 off of the side stack. So I'm just left with 2 of these little squares. Okay, so it just looks like a little 1 by 2 little rectangle. All right, then for figure 4, I'm going to redraw figure 3, right? So it had 1, 2, 3, 4. And then I'm just going to add 1 more on top. So 1, 2, 3, 4, and then add 1 more. Okay. Sorry, these lines are really tiny. All right, so there's 1, 2, 3, 4, which now makes 5. And then across, I had 1, 2, 3, 4. So then I'm going to add a 5th one on there. 1, 2, 3, 4, 5. Just kind of making that L. Okay, and there's our figure 4. So now it asks us to represent the number of tiles with an XY table. So I'm going to include 0, 1, 2, 3, and figure 4. And now I can just say the Y value should be how many tiles are in that figure. So in figure 0, there were 2. In figure 1, there were 4. In figure 2, there were 6. In 3, there were 8. And then in figure 4 that I just drew, right, I could add them all up, and I would get 10. Okay. So now when we go to write our algebraic rule, it's always going to be a y equals some number x plus something. Okay. Remember that the x number is our growth. So how much were we increasing every time or decreasing? In this case, we're increasing. The answer would be 2. We're going up by 2 every single time. So 2, 4, 6, 8, 10. This 0, we call this the 0 number. So when x is 0, whatever y is goes at the end of our equation. Like that. All right, and then last but not least, we are going to graph this. Now you guys will right now look at the table and graph these points. So 0, 2 would be 1, 2. I'm just going by a scale of 1. Just to speed things up, I'm not going to label it because it takes a while to label. For my x's, I'm going to move over 1 for this next point and then up 4. 1, 2, 3, 4. And then I'm going to go over 2, 1, 2, and then up 6. 1, 2, 3, 4, 5, 6. Over 3, 1, 2, 3. And then up 8. 1, 2, 3, 4, 5, 6, 7, 8. Last one, over 4. 1, 2, 3, 4. And then up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We can see that that will form a straight line. I'm just going to go ahead and connect those. Perfect, and that one's done. flipping the page over. All right, now it says that we need to examine the graph at the right. So this graph over here. We're going to use a graph to complete the table. So we're just going to fill in these numbers. So when x is -1, y is, let's see, 1, 2, -3. Okay. When x is 0, right, it's not moving over at all, y is -1. When x is 1, y is 1. So 1 and 1. When x is 2, 1, 2, right? How many do we have to go up? 1, 2, 3. So we're over 2, up 3. And then this one's going to be a 3. 1, 2, 3. We have to go up 1, 2, 3, 4, 5. Okay. All right, so now if we use the graph to find our rule, it's always going to be that y equals, remember, and then the next number is our growth. So I always put that box around it. Some number, x, plus something. So remember, in front of the x goes our growth. How much are we going up every time or down? In this case, we're going up, right? So every time we're adding 2. So it's always a plus 2. So we have 2x. Plus our 0 number. When x is 0, whatever y is, that number goes in here. So plus -1. Okay, you could also write this as y equals 2x minus 1. It's the same thing as plus -1. All right. Next up, circumference. Remember, the circumference is going around a circle. Okay, it's not all the stuff in between. It's just the distance around. And it does give us the equation right here. So circumference equals pi times diameter. For pi, we're just going to substitute 3.14 in for that. Pi is a number that goes on and on, never repeats, and it just keeps on going forever and ever. So we're going to go ahead and find the area and the circumference of this. It says down here. All right, so the circumference of a circle is the perimeter, or the distance around the circle. And we're told that we have to find the area and circumference. The diameter, this part right here, going on from one end to the other, is 15 centimeters. Just going to write that there. Okay. So the number pi is the ratio of the circumference of a circle to its diameter. That is, the pi equals circumference divided by diameter. That's all this is. So when we go ahead and try to solve this, it says that the definition is used as a way of computing the circumference of a circle. If we know the distance, all right, so here's our formula. C equals pi times d.